the last problem says, simplify arcsine of sine 5 pi over 6. Well, when we apply the inverse function to a function, you would normally write 5 pi over 6, right? But there is a catch to it, and it's not correct. In this particular case, we cannot really apply the property of inverse functions. The property of inverse functions does not apply. And here's why. When we look at sine, and we just did, since I have it up here, I just want to go back to it for a second. Do you see this is sine? The green graph is sine. Is it 1 to 1? By the horizontal line test,
yes,
sine is not 1 to 1. Because 1 to 1 means to each y there is only one x, but that's not the case here. So to this y value, I find this x and another x. For this y value, I find two x values. So function sine itself is not 1 to 1. Remember, only 1 to 1 functions have inverse functions. And you can say, okay, but if sine is not 1 to 1, why are you talking about the inverse function of sine? True. But we can, and we will, because we truncated the domain, we cut the domain of sine x only between negative pi over 2 and pi over 2. So therefore, when I write this answer does not exist. It's not in the interval negative pi over 2, pi over 2. So I cannot apply the property of inverse functions to 5 pi over 6 and just write 5 pi over 6. So therefore, I have to find sine 5 pi over 6. Sine 5 pi over 6, 5 times 30 is 150. It's this graph, 5 pi over 6. And the reference angle is pi over 6, so therefore this is 1/2. So I will first replace this piece by 1/2. So now arcsine of 1/2 is an angle here, which is pi over 6. So be careful, you cannot always apply the inverse function. It depends on the function, and it depends on its domain and range. So that's what happens with sine. Of course, they're all truncated. No trig function is 1 to 1. Every trig function has a truncated domain to make it 1 to 1. So we can determine the inverse, so that the inverse exists. So be careful with that. When we talk about the inverse of a function that is trig, we have to automatically think in terms of a truncated domain. This was a long one, right? Yes, please.
For the inverse cosine, is it 0 to pi?
Yes. Yeah. Because the graph of cosine is this. So here. So this is a complete rotation. I should say complete, we see all possible values. So that's why cosine has domain between 0 and pi. You can say, but I can find a cosine for any value. I agree. But this, when it comes to the inverse function, those two don't exist. Those sides don't exist. This is it. Yes, very good, correct. Okay, I think we are ready to start chapter 2. Well, chapter 2 deals with limits. Limits. But before we even talk about limits, we would like to go back to the graph that we just looked at a few minutes ago. In which we have a function, p, f of x, and a point p. And two questions we have in this first section, 2.1. It's called velocity and tangent problems. Velocity and tangent problems. So what are we trying to do here? We're trying to determine the slope of this line. Find the slope. So the key question here is find the slope m at tangent of tangent at p. What is the difficulty here with algebra, or what we've been doing in the past? I can find the slope of a line if I only have one point. And I only have one point. I have this x and f of x. That's all I have. So I can't find the slope of this line that is tangent. It touches the graph in only one point, because I only have one point. Here's what I'm going to do. Of course, you would expect that. I will determine the slope of a secant line, PQ. And you can say, who cares about it? Why do you care? Just find the slope of the tangent. That's what I'm asking you to do. Here I am creating a secant line, and it doesn't really matter where I find or I create this point. Let's say x plus a little bit. And I'm going to ask you a few questions now. Assuming I move this point Q here, and I draw the secant line. Let's say I move it here, and I draw the secant line. And on and on and on, and I get closer and closer to P. Not on top of P. Q does not become P, or P does not become Q. So I will say Q gets closer and closer, approaches, does not equal, approaches P. Would you agree that the slope of the secant line PQ must approach, I'm not saying equal, must approach the, okay, look at this. This is the first secant line, then this is the second secant line, and this is the third secant line, and even closer, this is the next secant line. The slope of the secant line will approach the, of course. As we get closer, Q closer and closer to P, the slope of MP, the slope of PQ will be closer and closer to the slope of the tangent line at P. Would you agree? Okay, one more. What will happen to H at the same time? These all happen at the same time. I bring Q closer and closer to P. The secant line gets closer and closer to becoming the tangent, or the slope of the secant gets closer and closer to the slope of the tangent. And what about H? What happens to H? Closer and closer to? 0. Exactly. None of these are equal. Specifically, not the equal symbol. I'm specifically saying do not consider that that becomes the same or equal. Okay. Okay, this is a concept that I would like to work on with a couple of problems. Ready? If you have your book, or if you don't, that's okay. Let's take a look. I would like to choose a problem from here. You choose. Of course, the velocity will be the same idea. What about something like this? Number 4. Let's read it. Is it clear? I can see from here. Is it? Okay. The point blah 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 lies on the curve y equals cosine pi x. If q is the point, use your calculator to find the slope of the secant line PQ. I don't need correct to 6 decimal places. For the following values of x. Using the results of part A, guess the value of the slope of the tangent line to the curve at this point. Ready? Okay, so let's look at problem 4 on page 86. I'm going to copy P, 0.5, comma 0. Q is x comma cosine pi x. And I am going to copy the values they want so I can put the book aside. So 0, 0.4, 0.49, 0.499, 1, 0.6, 0.51, and 0.501, I think. Yes, it is. Oh, I'm sorry. Sorry. Okay. So here's the idea again. We have P, 0.5, comma 0, and we have Q, which is x, comma cosine pi x. We want to determine the slope of this line. Can anyone dictate? The slope of the secant line PQ. Excellent. Cosine pi x minus 0 over x minus 0.5. Do you all agree with this? Now I would like to present an order, the values that they are asking us to determine this slope for. In the correct order, please, from left to right. So this is the slope of the secant PQ. So it's 0, it's 0.4, it's 0.49, 0.499, it's 0.5, it's 0.501. I ran out of room. Don't be surprised. I will always run out of room. 0.51, 0.6, and 0.1. I'm sorry, and 1. So this is the continuation. Here's what we are going to do next. We're going to grab our calculators and go to y equals. And we're going to delete everything we have, clear. And please put in, this is a ratio, We should always have parentheses around the top and parentheses around the denominator. However, because it's minus 0, there is no operation there. There is just one term, so you don't really need parentheses right now for the top. So cosine pi x, cosine, make sure your mode is in radians, cosine pi x divided by, in parentheses, x minus 0.5. Close the parenthesis. What is the first value we have to plug in? This software always goes back to default, so please go to second and table set and make sure that your independent variable is in the ask mode. Just the independent variable in ask mode. And then go to second and table. If you need help with the calculator, please let me know. Are we okay? Are we all here? Yes? Okay. Good. So which is the first number we plug in? Very good. 0, 0.4, 0.49, 0.499. Can I plug in 0.5?
Can, but it'll give you an error.
Okay, good. Good point. 0.501. 0.51. What did I do? Okay, it was 0.499. Okay. 0.501. Okay. 0.51. I think it was 0.6 as well. And 1. Okay, I'm copying those values. So -2, -3.09, -3.141. I don't need 6 decimal places. If you want, you can. I don't care. The concept is what I'm interested in. Okay. -3.141. Okay, my 0.6 disappeared. What was 0.6? -3 point and -2. In part B, the problem is asking us to determine an estimate, find an estimate of the slope of the tangent line to the graph at 0.5. So notice that we're getting closer and closer from either side. So this is 0.5, 0.499999999, 0.500000001. So from either side, we're getting to 0.5. So what will be your rough estimate? And before you answer, you could say, 0.499 is not close enough for me. And I'll say, okay, 0.49999999999. I hope it takes it. I don't think it's going to take it. I have to. It's too much. It's going to give me an error. I'm pretty sure. Okay, maybe this is good enough. So it considers this at 0.5. It doesn't give me an error because it considers it not close enough to 0.5, not identical. So what is the slope of the tangent line? -3.142. You can go and watch this, maybe closer. -3.1416. So the slope of the tangent at P, -3.1416. Did we understand the concept? Do we understand what we did? So we brought Q so close to P that they were so close that that slope that we determined of the secant line became so close to the slope of the tangent line. And we determined a very good approximation, maybe this may be exact, of the tangent line at point P with only one point, which we did not know how to do in previous classes. Any questions?
When I entered in the data on the Y, I got completely different answers. I'm not sure.
Yeah, let me take a look and see if you have any radians. Yes, you are in radians. Let's look at, yeah, you omitted a parenthesis here. You put one too many. Yeah. Yeah, one too many. Okay. You're welcome. Good. Do we would like to see another example, yes or no?
Yes.
Perfect, awesome. Okay, what about number 8? This time we are talking about a velocity. Okay, number 8 on page 86. The displacement in centimeters of a particle, the distance formula, moving back and forth along a straight line is given by the equation of motion. S of t equals 2 sine pi t plus 3 cosine pi t, where t is measured in seconds. Find the average velocity. The average velocity between 1 and 2. The average velocity between 1 and 1.1. The average velocity between 1 and 1.01. And between 1 and 1.001. And then estimate the instantaneous velocity. I need to write this with you. Finding the slope of a secant line is identical to finding the average velocity. It's still the same thing. 2 points on the distance formula. Same thing. y2 minus y1 over x2 minus x1. So finding the slope of the secant line is identical with finding the average velocity. Also, finding the slope of a tangent line identical to finding the what do you think?
Instantaneous.
Of course. Velocity. They are identical concepts. They are determined in the same way. Everything the same. Okay, so let's create our table again. Average velocity, which would have been the slope of the secant line, the same thing. 1, 1.001, 1.01, 1.1, and 2. Can anyone give us the formula for the average velocity? So before we had, remember we had the 0.5 comma 0. Now we have a 0.1 comma s of 1. This is from the previous problem, but obviously everything refers to 1. The reference number is 1. And eventually we will be asked to find the instantaneous velocity at 1. So this will be point P, and of course point Q will be t comma s of t, exactly what we had in the previous problem. So can anyone give us the formula for the average velocity? This minus this over this minus this. Any questions? Yes, please.
I was just wondering, is that the rate of change?
The same thing. The rate of change, yes. The rate of change of the distance with respect to time, which is average velocity. Yes. Same thing, identical. So average velocity, please dictate. Excellent. Okay, we can write it like that. But I want it specifically for this function. 2 sine pi t plus 3 cosine pi t minus, we plug in 1. 2 sine pi plus 3 cosine pi over t minus 1. One more time, the points are s of t, which is this, minus s of 1, which is this with t equals 1, over t minus 1. But sine pi is sine is measured on the y-axis. Sine pi is
0.
perfect. Cosine pi is
-1.
perfect. This is -1. So 3 times -1 is -3 with minus in front is +3. So what we are going to plug in the graphing calculator will be 2 sine pi t plus 3 cosine pi t plus 3 divided by t minus 1. You can say, I don't want to create this function that you just created. I want to do it by brute force, just plug in the numbers. That's fine too. But I don't want to plug in 4 numbers and redo the calculations 4 times. When I can create this function and plug in this, and just write the numbers underneath. But if you want to repeat the operation, that's fine too. It's nothing wrong with it. So, clear? Now we need parentheses for the top. 2 sine pi t. There is no t in the graphing calculator. I didn't mean that, of course. Sorry. Parentheses. 2 sine pi. Why isn't it doing this? Okay, one more time. 2 sine secant pi. Okay. X. Close the parenthesis. Plus 3 cosine pi. X. Close the parenthesis. Close the parenthesis for, no, plus 3. Don't forget plus 3. Plus 3. Close the parenthesis for the numerator and divide by parentheses x minus 1. And of course, we go back to second and table. What are we plugging in? Let's go from far to close. It doesn't matter. The order is not important. The average velocity between 2 and 1. So let's plug in 2. Then we plug in 1.1. Then 1.01. And then 1.001. And you can say not close enough. Okay, I agree. To find instantaneous. And let's see what that is. So the first slope, so under 2, I will write 6. Under 1.1, negative 4.712. Under 1.01, negative 6.134. Under 1.001, negative 6.268. And what will you conclude? What will you conclude about the instantaneous velocity at 1? Instantaneous velocity at t equals 1. What would you say that will equal to? Negative 6.2832 meters per second. How come it's a negative velocity? It's only it gives us a direction. Positive velocity, negative velocity. It means that it's not going away from where it started, but it's coming back. That's all it means. Any questions? Yes, please.
I don't know when my table came out totally different.
You have a parenthesis, an extra parenthesis here. That's okay. I got it. X. I'm going to start from scratch, I'm not sure. So it was 2, what was it? 2 sine, okay, sine pi x, and plus 3, right?
Mm-hmm.
Cosine pi x, close, divided by.
2u plus 3.
I have to do plus 3, thank you. Plus 3. Plus 3, close the parenthesis, and divide by x minus 1. And 0. Oh, you're not putting your numbers in.
Oh.
You would have to be in the ask mode.
Oh, okay.
Otherwise, the calculator will put the numbers in once. Okay. So, yeah, you forgot this. So, second and table set, you have to make sure that the independent variable is in the ask mode. Any questions? Oh, yes.
How do you get that 6.2 number? Because
Just go scroll to the right. But what we did was we put in 1.000000001. We press enter and then go to the right to see it.
Oh, okay, thank you.
You're welcome. Any questions? Any questions? I was hoping we would get to 2.2, but we didn't tonight. So, any questions for anything about anything we've done here? Anything?